Hey everyone, now we're going to be going over examples for decreasing time algorithm. Decreasing time is very similar to priority list, except now we have to create the priority list. So to create the priority list, we're going to look at all of the numbers in our project diagram and we're going to list them from greatest to large or greatest to smallest. So we're going to decrease the number. So our biggest number on this project diagram over here is a 10. So we're going to do D for 10. Then we have a 9, which is B. Then an 8, which is E, then a 6, which is F, then we have C, then we have A, and then lastly we have G. So this right here is now essentially our priority list. We just create it using the decreasing time algorithm. Pretty simple to create the decreasing time list. So now what we're going to do is just look at our project timeline examples. Instead of trying to go through and do each of them, we need to figure out which one of these is the correct answer. So we're going to save a little bit of time. So as long as you understand what we're doing, it should be straightforward to eliminate the wrong answers. We know that only A, B, and C are eligible at this moment. So we can only start by assigning A, B, or C to one of our 2 processors. So N equals 2 processors. Well, using our priority list, or decreasing time list, we want to optimally start with D, but we can't get there yet because we haven't finished A and B. So now we're going to move on to B. So B is the first thing we're going to assign to a processor. So we're going to put one line through it. All right, well, we have a B, and a B here. So now we're going to move on, and we need to give processor 2 something to do. So we've already started B. Well, we can either do A or C. They're the only 2 that are eligible. So which one comes first in our decreasing time list? C comes first. So we're going to assign C first. So right here, we're going to give C to processor 2. All of our examples or all of our answer choices have that next. All right, we're going to move along and we actually finish C. Well, if we finish C, we can circle E. So now we need something for processor 2 to do. So they can either do E or A. Well, which one are we going to do first? Because we've already finished C. We're still working on B. Are we going to do E or A? Well, E comes first in our list, so we're going to start with E. So let's look right here. Well, this one starts with A and this one starts with E, or with A also. So the only option is B. Now we can continue. All right, we go through, we're working on E, then we finish B. Well, now we have to work on A, so there's our A right here. We start working on A. We actually finish A before we finish E. We move along. We're right here. Now we finish A, we finish B, so we can circle D. So we can go ahead and assign D. And we move along. We finish E. We can circle G. We assign G. We finish G, but then now we have to sit here and wait until we finish D. Once we finish D, then we can circle F, we can start F, finish it, and then we're done. So we have all this idle time right here. Now what is our our project's finishing time? We're going to take our project timeline and we're going to see how long it took to finish. So we're right here at 27. So 27 is our project's timeline. Now we're going to do the same thing for exercise 2. So consider the project described by the diagram shown to the right. Assume that you are to schedule this project using 2 processors. So we're going to do the same thing, but we're going to create our decreasing time algorithm just like we did in the first example. So decreasing time, we're going to start with the biggest number on our graph. We have a 6, so we're going to have D. And then we have a 5, which is B. We have a 4, which is F. Then we have E, A, and then C. So this is essentially our priority list. It's called our decreasing time list. All right, sorry, my handwriting's a little messy. All right, so we're going to move on and look at our examples and see which ones are eligible and which ones we can start. Well, we can go ahead and start A, C, and E. Which one are we going to assign first? Well, we want to do D. We can't do D yet. Well, we can't do B yet either. What about F? We can't do F. All right, what about E? Yes, we can start E. So we're going to start E and we're going to assign E to the first processor. Well, this one doesn't even assign E to our first processor, so we're going to go ahead and eliminate that one. And this one does here. All right, we're going to keep going. We've started E. Oh, sorry, wrong one. We started E. Now we want to do either A or C. Well, which one comes first? A comes first, so we're going to assign A to our second processor. All right, this one assigns A. Well, this one doesn't. So this is a wrong answer. We've already got the correct answer. Now let's go ahead and finish this. Guys, our project finishing time is going to be 14. All right, now we're going to answer the question of finding the optimal schedule and the optimal finishing time, and then we're going to calculate the relative error of the decreasing time algorithm. This relative error formula is the same as what we've been using for every other chapter for relative error to figure out the efficiency of this algorithm. So the first thing we need to do is look at our choices. We have A, B, and C. And all we need to do is figure out if they follow the rules. Does A come before B, C before D, E before F? Do they go in order of our project diagram? So the only ones that are eligible is A, C, and E. So we're going to look. Can we start with B if only A, C, and E are eligible? No, we can't start with B. We haven't finished A yet. All right, what about, can we start with E? Yes, we can start with E or A. So both of these so far are good. All right, next thing, we go on, let's say we start E, we start A, and we finish A, we can circle B. So now which one are we going to do next? So we just want optimal. We don't really care about a decreasing time or any kind of a priority list. We just want to know which one is optimal. So we need to see if these are actually possible. So we could either start with B or C for that. So this one starts with B and this one starts with B. So we're good. So we're going to start with B. All right, we're going to move along. We finish E. We can either do C or we can do F because that one is now eligible. So right here, can we do D if we haven't done C yet? Well, C's not done until back here. So we can't do that one. So that eliminates this one. So this right here is our optimal finishing. So our optimal finishing time is going to be right here at 11. So optimal finishing would be 11. So using the answers in the previous example, so remember back at the first example, we had our optimal time was 14. All right, so we're going to take our 14 that we got from the previous one minus, so that's our algorithm's time, minus the optimal, which is 11, and divide it by our optimal time, which is 11. And we're going to multiply it by 100% to get it into a percentage and round to 2 decimal places. If we type that into our calculator, we have 3/11, which is 0.2727. So we're going to have 27.27% as our answer.